Just have my mic low because this fan is a bit loud. I can probably improve it. Doing a couple of things. Just have my mic low because this fan is a bit loud. I can probably improve it. Sorry. Right. I'm just working on this documentary parser for TLEX. Swanage.com. Right, so instead of match row, we're going to have condition sequence. So basically, not only does, so we can, if we look at our roles for the parse tree, the majority of them like even this root rule here, it's just one child rule. Okay, so currently we allocate a whole parse condition sequence with an array of conditions, and that array just has one condition in it, and that condition has we do need to know if it's optional or not. It just has a p-parse condition for the child rule. No, it has a s match rule for the child rule, which does this when it runs. So this whole thing, I think, maybe just to get rid of it, in the match rule case, instead of having, since this is just a virtual function, the parse condition sequence is a virtual function. So I think we should have a parse condition that's just a child rule, simple child rule. Or is it just, is this the right thing? So yeah, if we use a generic, then that generic base class, and instead of this if part of the condition, we will instead have this if condition.p-parse condition, which does this recursively but generically over here. Okay, so yeah, make a copy, no need copy, if test condition, that'll just become a virtual function, which is what it does anyway. To get to the rule itself, why not just add a pointer to the rule? Wait, what? I'm getting confused now. What? Oh no. So we have so the parser, the starts parsing at a p-condition, which is the root rule the root rule is what? sequence. So instead of a sequence, that'll just be a parse condition child rule, which is this thing I'm about to create. Okay, but should that be one child rule or a sequence, or should it be parse condition? Should it be generic condition? No, it's child rule specifically. Okay. So this part, yeah, that says match rule will become child rule. So it's the child rule name. Okay. So then we're going to have a virtual function. So instead of a sequence of conditions, we're going to have two things. Child rule name, and then possibly the actual const pointer. Or just a pointer, I don't even know if that makes sense. Okay, the child rule itself, which will be null until we do the prep tree thing. Okay. Alright, then we're going to implement this. Let's just put it here. So instead of a S match rule, basically this logic here is going to go in that function. But the part about this part we don't need to do because the caller is now going to do that. Right? Yeah, the match recurse and the node eat stuff. It's just going to call, yeah, it's going to call, yeah. Okay. Why does it seem like we still have an unnecessary level of call? The first condition will be the root. So in the root, and the root will have a, no, the root doesn't have a condition. But then we won't get ya. How can we get ya? If the root doesn't even have a condition. Oh, it won't. We don't need to, it doesn't need to get ya. The thing that will be doing it, because the root rule, this is, this stuff's confusing. It's very, anyway, the root rule, parser, parse, right? Parser parse starts at the root rule. And the root rule has a pointer to a condition. Oh, so yeah, it'll never get there. But then this needs to do that. There is no copy because... but then this question is now answered. Should we make a copy of node eat? So the answer is yes, we'll have to make a copy of node eat because... No, we don't. No, we don't. But then this child function does need to do that. But if the child function needs to do that, that's not efficient. Because it's already doing that, and then it's going to do it twice. For these cases, when a condition points to a child rule. Maybe I must keep the condition, not get rid of the condition. Still have the condition sequence, just not a S match rule. But it's still going to optimize away, there's going to be no condition. Why do we need a condition? I mean, why do we even need this? I mean, it handles the logic of the way that it's optional or not. Why isn't that in the rule? Like, yeah, okay, like that could be optional rule, blah, blah, blah. Okay. Like this could be rule lemma or rule lemma foo, okay? Or even element. So then the root rule will be, the root rule's precondition will be a sequence, an OR sequence. And then in that sequence, there'll be not a sequence, it'll be an OR. An OR thing with 3 sequences. And the sequence will have one condition that's optional, and an optional condition. Something doesn't make sense to me because yeah, when we recurse, why do we, if we don't need the condition, what? I don't know. Here, make a copy. If the caller makes a copy always, like let's say that the root rule is A or B or C, right? Like that. Then it searches for A, gets halfway, then fails. That call to parse the actual excuse me, yeah, this one, line 70. That condition is the OR. Yours parse condition looks like this. Okay, so for each one it does make a copy. Makes a copy, and only if it's a success, then it assigns or sends the result back. So that's fine. But then we need to do the same. But if we're doing that inside parse condition test for the parse OR, why wouldn't we do it for the child rule one? Now, if we're doing it inside parse condition test, yeah, then why do we do it when we call parse condition test? Oh, because the rest of the sequence may fail. So wait, our little part succeeds. Yeah, why do we do it here then? Isn't it getting done twice? I mean, if that thing makes a copy always, internally, then why do we need to make a copy when we call it? Now, the other thing itself is this function is in fact also a parse condition test. The root rule has a sequence. Or itself is OR in that case. But aren't we making copy twice then? Infinite. I mean, either it must happen in the function or the caller must do it, but it shouldn't be both, because then you're just doing it twice. Unless I'm confused. Yeah, tired. We still have to do the logic of whether it's optional. So I think even if we refactor this now, P rule, P condition, parse condition test. Right now what that thing is the sequence. It's always a sequence. Always, always, always. And that's what I want to get rid of. Look, the child rule has a pointer to a condition. So if we open these folio rules, root equals blah blah. So that'll allocate, a sort of root rule that's just a pointer to a sequence. A sequence is one condition child rule, and that condition child rule will have a pointer to a rule that itself is a pointer to another sequence with a condition list of 1 with one S child rule. It seems a little inefficient to me, so why do we need the condition and the sequence for such a simple thing? We do need to know if it's optional, but that's all. Let's put this back for a second. Okay. It's not optional. It's compulsory. So why do we need even to have logic of whether or not it's optional? See, I'm thinking of a finite state graph, okay? You have your node, okay, for your root. And then you must pass through the node for the rule main def group, okay? It's not optional, and then you must pass from there to, or fail, boom, from there to the rule lemma. And there you must pass to the, so if one of these was optional, now from a finite state graph, persistence is not optional. I think we should have different cases. We could have a pause condition, optional, that has a pointer to optional, and then the pause thing itself, its pause function calls that match equals optional pause, and if not a match, turn true anyway. Because returning true, else, so it'll fail, not a match, but so it'll discard any results, not a match. But if it's optional, it acts as if true by going on to the next instead of failing. So an optional never fails. So I think the very notion of an optional itself could just be re-implemented also as just a special derived case. And then any non-optional rule can just be a straight pause condition instead of an optional one. So the optional logic is just, you know, if this was optional, this is a bit confusing because I'm using this to indicate optional as well as to indicate to draw little boxes. But if that was a little box, okay, if this was an optional rule, then we could either pass through it, as a main diff group, or pass through it like that, onto the next. Or actually, something like that. Yeah, so if that's our failure lemma box in the chart, that logic is represented like that. Okay. So the very notion of optional, we don't need a variable. We just create a different class. And then we can optionalize anything that's like this can be a sequence, or it can be a simple case of a child rule, or whatever the hell it is. Okay, I think that's sort of, so if you think about it as a finite state machine, which it is, that's what I'm trying to, it's not very finite statey. It's sort of pseudo finite statey right now. Anyway, alright, so the one thing I do want to try speed up here is just have this. Okay. So match rule is actually, it's not even child rule, it's just match rule. Yeah, it's the rule we want to match. We want to match the following rule. I guess it is in a way, yeah, those are the children. But it's not to be confused with the child node rule. That's the actual child node rule, match rule. I don't even think it should be called a child rule, let's call it a match rule. So S match rule, yeah, where we have S match rule, we just do this. Condition, now we're modifying it, okay. So not a constant anymore. And this should now be done in the prep tree thing. So condition match if it's null when we look it up. Okay. If it's null, it's an actual error. Note, if it's null, it's an actual error, not just a failure to parse. But hold on, syntax error in your, not a syntax error, logic error in your parse. The definition, parse configuration. Just have to match. It should okay. So yeah, we do that. Why do we need the rule? Why would we need the rule? It's got things like the rule name. Just pause the rule. Syntax error. Go to hell. Am I blind? It looks fine to me. Syntax error. Semicolon bullshit. It had nothing to do with that. Alright. Gosh. Just working on a final state. Parsing in memory for complex multipass XML to XML territory modeling task. Okay. So now enable that should give a slight speed up in theory, but maybe not even noticeable. Well, I'm now running in slow mode and I'm doing other tasks and have a lot more things open and I'm streaming, so all that will slow down, all that will slow. So yeah, to parse 206,000 entries and get 25,000 matches, about 10 million nodes or something in the 13 million nodes in the directory, took only 3 seconds. So this thing is really fast. It's already very fast. So any speed ups I try to do, it's not going to be noticeable. Less than 3 seconds. 2,600 milliseconds. 2.5 seconds. About just 2.5 seconds basically to parse this massive document tree with about, let's see how many million nodes. There's 13 million nodes in the DOM tree in the database. In memory, we have about, elements, 11 million elements. So to parse this complex thing and return the 25,000 results, 2.5 seconds, it's really fast. It's really quite tight and optimal already. So so that thing I just did now, matching up the pmatch rule, that should happen there should be, like, before it even starts to parse, it should just call something like prep the parse graph or something. Anyway, so I don't see why I even need that, because all that child rule is a pointer to the condition, and the condition itself is a sequence. So this very call then goes into something that looks like this. Boom. The same, another instance of this that then loops over all these conditions. So if we have one rule and it's not if we have just one child rule and it's optional, if we go into the loader, right, the thing that creates this S match rule, yeah, boom. All right, so we can test. Okay, that's a special case, but this part here, right, the all factors, and then it's yeah, the rules, yeah. If as.size actually it's got nothing to do with as.size, does it? Huh? So what we're creating now is basically like the root rule is appointed to a sequence which has an array of conditions, and that one condition is a S match rule condition main def group. Okay. And that rule itself, main def group, is also a sequence and the value name itself is a sequence, but this has value name is a lm, and with the child rule value name is kids. And that specialized rule value name is kids. And finally we have a sequence that actually has a sequence. So there's so many sequences, condition. This whole thing is so inefficient. The graph it produces basically looks like that. Okay. Kids is finally a sequence, it's a sequence of like this. I'm in the wrong file. This is an absolute mess. But anyway, so that's a sequence A conditions. Okay, and first condition is LM lemma. Second condition is an optional, and then we have the third condition, etc., etc., etc. Okay. And that rule word itself is a sequence conditions to match LM lemma words. Right. It's quite a weird concept what I'm doing. Like, it's not weird. It's just, I'm not parsing XML. I've got a, the data is already parsed and it's in memory, and it's in memory as a document tree or a node tree. So each, entry in the dictionary has a hierarchy, hierarchical structure that's like XML-like elements and attributes and text nodes, and parts of it are well structured and parts of it are not well structured, and the job I'm trying to do is parse the entries that are not well structured into better structured entries. But all of it is in memory DOM, document object tree. So all this is in this is not well structured parts. Okay, so all this is XML parsed into memory already as a node tree. And now I'm writing a parser that literally parses the actual node tree in memory. So it looks for, node of this element type followed by optionally part of speech, and then maybe sub-entries that look like this. So it's actually, the parser doesn't parse XML data per se, it's parsing, we got classes to represent a tree of data in memory, like a base class. Each tree is a node, and that node is a TC node, class node. There's a class called TC node, and each node, in the tree, is a node with information like the type and the number of children, the child nodes. So there's a node, there's child nodes, and each child can have its own children. Okay, so we create a finite state based parser that looks for rules, that has rules, so that looks for content. It goes over a TC node tree in memory. So you give it a pointer to a node, the failure lemma node, and it looks at its rule and says, well, the rule says I'm looking for a failure lemma node. Here's one, boom. So we succeed. Go on to the next rule. The rule says, okay, the next thing to look for is, we're looking for a lemma node. Is there a lemma node? Yes. Boom. Parser advances to the next node. So we're telling it the structure, but it's parsing that in memory, and then I can use that information to, as I'll show you, if we find filter all that match the parser, what it's actually doing, and we can actually see, look, that now this is really interesting. Those little things in square brackets are the actual rule names. Here's the proper rules. Okay. And the nodes they're matched with. So our word, that's the part of speech. That little thing in square brackets, that's the element name, and that's the word. There's our rule, failure limit kids. Failure limit kids. So it says that that rule match this node, or these nodes, and this morph rule matched the limiter, and this that's two things. A B for the I don't remember having a B rule. What's a B? Oh, we do have a B. A or B. Oh, it's a definition. It's a definition case. Yeah, and that's the definition which is a type of example. So yeah, it's parsing really well, and we can actually see what the parser's results are on the document tree by looking in the tree view, which is very powerful. It's amazingly powerful, and then we can use this in. What's really cool about it is it integrates with the filter system in TLEX. So the parser, when you apply it, also becomes a filter in the filter system, a user filter. So it filters 25,000 entries that match the parser. And we can change the rules slightly, like if we add a few more rules to identify some new thing, and then we can test it and what's really cool, yeah, we can actually use the filters to subtract the results of one pass from another pass. So if I had a rule to find some type of information that's not currently being found, and then we get 30,000 matches, there'll be two separate user filters here, and I can subtract the results of one from the other just to see only the entries that my changes to the rules now additionally identify. It's extremely powerful. And then we can do things like just tag those specific ones, or or subtract it. I can load the tag set of the entries I'm supposed to be changing, which is 119,000, and then I can actually use like these filters to subtract the ones that pass the filter from the tag set. So it shows me only the entries that I need to convert that don't match the parser yet. So I can go look and say, well, why doesn't this match the parser? Oh, I see, because I can't handle the references node in the inside the definition yet. That's really, really neat. Really neat. It's very super powerful. And then there's a whole integrated conversion system. So I can then select either tagged entries or filtered entries, or manually just select the entries. And then I can apply my conversion scripts to those entries by using, so run XML to XML multipass conversion scripts. And that's a multipass thing that has regular expression search and replaces, XSLT, Lua scripts, running in a multipass fashion that then takes the data in the entry that's been identified by the parser or whatever, and converts it into the proper structure it's supposed to be in. It's super powerful and really cool. I'm really impressed by the speed. But it's going to slow down as I add more rules, and especially once you start to get like, if you start getting ambiguities and stuff, then the pass speed can really slow down. And if you're not sure why or where, it can be difficult to debug that. What I want to do, show debug info. Okay, we're on the wrong file now. I want it to be in that backup file. want to play music, but I'm going to get copyright violation because I'm on YouTube now. So I'll play music later. I'll restart the stream, and not on YouTube. I just want to do a watch me work stream. So yeah, anyone who wants further information can do that. Blah blah blah. Stilex. Show debug info. Find filter all entries of this type only that match our lemma parser. Just want to test the speed again. Yeah, 2600 to 2700 milliseconds. 2489. So yeah, 2526. So in theory, it should be slightly more optimal to get rid of all some of these. You know, I'm generating a sequence of conditions to match a rule, blah 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 blah. Why not just generate and the rule itself then has a pointer to sequence. So why not just point straight to that rule's condition? Boom. Skip all the fluff. For now, I also want to just change it to not a sequence, but a match rule perhaps. But I'm confusing myself because that match rule is just I want to create a dumb little rule wrapper. Just as a pointer to the rule. I think we do need that. We do need that little layer. We can't just point straight to the rule's condition, because then we won't know what rule it is. If we point straight to the condition, we know nothing about the rule. So we do need the rule, I think. So we need something like match rule. I think, I don't know, my head is like, I'm a bit confused here. So something like match rule. I'm a little bit confused also about whether the caller in this case must be making a copy. But anyway, so basically what this must be doing is it's also confusing me, because the only way this gets called right now is through a condition. If we don't have a condition, then how are we even going to get anything called? Oh, it'll create one as a top level. The root rule. The root rule will either be a sequence of conditions or a pointer to. So in that case, a simple case will be then also a parse condition match rule as the top level rule. So that's what we want instead. That's what we have currently. What we want. And the rule itself then has a pointer straight to this one is different. It's not a match rule. It's something else, a match condition. Okay, so this one might still be a sequence. Okay, for now. But not ideal either. And the photodynamic kids itself will be a sequence because it is an actual sequence. In theory, it should be slightly faster to do that instead of that, but I think it may be negligible. Or slightly slower, even if. But yeah, basically, this whole logic should disappear. And the concept of optional, if it's optional, then it should work differently. So like if we look at LM8 head, okay, that's optional. Let's say we had root equals A or B. No, root equals A comma optional B or C. So those are the three cases. We can either have a document tree that consists of an A followed by B, A, then A equals, what we want is a parse condition match rule A, and B will be a parse condition optional with a pointer to a match condition rule B. Okay. The root itself will be a parse condition or, and we have such a thing, we have in fact such a thing, exactly such a thing. I think it has a different name. parse or yeah. And that has currently an array of sequences. I see. Sorry. Sequence. So currently the optional logic is handled in the condition stuff, which I want to get rid of and replace with. So then what we'll have is just like that, yeah, just fine. Because A is not actually defined as anything. We need something like A equals LMA, B equals LMB, and a C equals LMC, right? Graph. How's graph? Finite state. You could think of it as a finite state graph. Oh, it is. You don't have to even think of it as one. It's a bit weird that the parse logic lives inside it. Yeah. If we have a generic graph, then actually the idea is we just have nodes. Each node in the graph has a pointer maybe to oh, no, it's not. It's normal. It's fine. Anyway. This does seem simpler somehow. It's not slow. I don't need to speed it up. It's 3 seconds to parse that gigantic tree. It will get slower, but even it will be in the order of it's going to be manageable. It's never going to not be manageable. It's the same thing. Okay, just like that. Then big question, should we make a copy of node ETIA or just pass it in? Currently the way this is used, the caller does that. I might change that. If you take classes out as well. Alright. So this logic now of a match rule is when it's embedded as a condition. And then instead of creating a S match rule condition, we're gonna create a so now match is rule condition, parse condition test, parser edit rule and match bar. I feel like we should be making a copy of that nonsense, but so now if I, instead of doing S match rule, I create it as a p parse condition, which is an instance of this class, then it'll do this generically over here. Like so, we can have the root will still be a sequence of conditions, but instead of a S match rule, the root will be a sequence of conditions. So we're going to have an intermediate step. The root will be a sequence of conditions where we have a parse condition. One condition, that's a peak parse condition. TP parse condition match rule. Main diff group. Okay, so instead of S match rule, and this logic here makes copies. That's why I don't want to make copies inside the function. Or must we? Because the function itself that calls that. Wait a minute, I'm confused. I think we must anyway, because the copy is not for us, it's for the caller. I don't know, I'll think about that now. Parse condition test. So parse condition test for this. This could be sped up into prep graph. Okay. Oh, but we've been passed the copy, but why do we need this? Because why don't we just point straight to the next thing? Because then we don't have the rule. We could point straight to the next thing, but we'd lose Why can't each thing have a pointer back to its rule? Because I think it's so yeah, instead of this, that's a special case. Else, so now instead of what? Right. Pause condition equals new. That's rule. Okay. Maybe we can't map imperial in the construct here. For these two reasons. One, it may not exist yet. We're still designating the roles. And it's a reference to future. Then future loaded role. And having variable stuff to work. But anyway, it's going to be handled differently. Okay. This should be pause condition. So now instead of creating an S match rule, except for the null case, or alright. So whether it's optional or not, okay. So look, yeah, we create a sequence here. Now we're still going to be creating a sequence. One condition, pause condition. So now we've done it basically, it's just a slight refactoring, but the logic is exactly the same. There's literally no change, and there shouldn't be any speed gain. we can maybe get a tiny speed gain by commenting this out, or yes, now we're not using that anymore. And also, if we reorder some of these, like the null node is more rarely used than a parse condition or a text, so we can do the null node check last, perhaps. That's I don't think that's really going to make any material difference to the speed. If we were literally, you know, if the order of parsing was minutes and it was 10 times bigger database, yeah, okay, we might be seeing differences. But I'm not going to see the difference between, you know, there's just noise. Like right now, the variance 2,600 milliseconds, and then the next is 2.4, and then the next is 3,000 milliseconds. You know, if this thing is suddenly, there's so much noise in there, I'm not going to see if the thing runs at 2.5, if that goes fast or slow, or it's just in the noise still. Plus I'm streaming, you know, that also makes it less stable. But like even sometimes profiling stuff, it's so weird. Like even just, you know, I can run this thing you know, I can probably be doing speed tests of something that you're trying to optimize. And like you're getting 3 seconds, 3 seconds, 3 seconds, 3 seconds. And the next day all you do is restart Windows and try the same thing again. And suddenly you're getting 4 seconds, 4 seconds, 4 seconds, 4 seconds. So it's sometimes difficult to, you know, something somewhere, you know, either Windows setting is changed, or, you know, there's so many things that can affect it inadvertently. Like if your CPU is busy, you might be inadvertently getting throttling, you know, or, you know, just different stuff loads in different order in the operating system, and suddenly pages that were aligned yesterday that helped you speed-wise are not aligned in memory anymore, you know, or Windows is doing some shit in the background. There's so many profiling, you know, it's not only noise, you know, somewhere you've got to discern the information out of the noise. What have I done? I've added a lot of nonsense into. Huh? Oops. Did I run with that? That could have affected the speed if I ran the last test with that. But anyway, like, yeah, look at that. I mean, I just did the same thing that was. The first time is also usually slower because, not usually, but sometimes, I mean, not always, but it tends to, on average, be, you know, the first run of something is slower because the second time everything is more likely to be in memory cache, you know, the CPU cache close to memory. The CPU cache, you know, the first time you run a task, it has to go fetch those code pages in from memory into the CPU cache. But the second time you run it, they now may be in the CPU cache, so that's why you tend to see that sort of thing. It's good to run it a few times. 28, 28, 28. So that looks slightly slower. Well, I'm not sure. 27. It's just, it shouldn't be slower, damn it. It should be the same. It should be slightly faster, actually. 28, 27, 27. 28. But it's not slow. I don't know. I'm also running this, so that's what I'm developing. I don't know if you can see that. Chrome as well is a pain. It's Chrome 2929. That's what I'm working on. I'm a bit concerned that I'm not getting 242424 like I was. I don't see how this can be slower. It should be, if anything, very marginally faster. Because it doesn't have to... Actually, no, wait. I'm lying. No, it can be slow because it's now 2 function calls. Because here the condition would just cause one function call. Now we got this pointer to a parse condition, which calls the parse condition test. And that then calls the rule condition. Yes, so we now got 2 function calls instead of 1. That could explain a splat speed decline. Let's just put this S natural stuff back. And put back to how it was. I should have also checked that the results were still the same, because it could also be slower because it's working wrong and it's returning more results. I might also have been running it on a different database. Let me just think clearly about all the factors, make sure I'm running on the same database, and check the result count is the same. Because if my logic is now wrong and it's returning twice as much, that could also explain a slight speed difference. So yeah, make sure we're on the right thing. Show debug info, right click on all nodes of this type only that match the parser. Okay, it's got the correct number of results, so the logic is right. I think it's just because I've managed to create an extra function call layer that's not necessary. I'm not sure it's slower even, it just feels You know, 29, 28, 31, 32. Let's put it back again. I need coffee. Show debug info. I mean, look, I'm not complaining about the speed. 3 seconds is very fast for what it's doing. It's like, I can't even believe it's that fast. You know, there's 10 million nodes in the document tree, 11 million nodes in the document tree, 206,000 entries. That looks about the same. It's not faster or slower. It's literally the same. Or I'm not seeing, like earlier I was getting 2.4, but I wasn't streaming. You know, so the streaming slows down the machine. And add some noise to 273. Sorry, my fan's loud. So it's the same. It's not slow off. But I'm in I still don't think it's good or healthy to have an extra function call. Because what have I done? I've created a sequence of conditions and a p-parse condition. And that p-parse condition calls parse. Wait, that p-parse condition parse calls the rule parse. So the sequence parse function calls the condition that parsing is a parse calls the rules of parse, which previously the sequence parse calls condition rule parse, child rule parse. Yes, there's an extra layer now. How do we get rid of that layer? I don't see why I don't just point straight to that. It doesn't exist yet, but so we can't point it yet. But I thought this would be a very quick change. It's not. I must leave it and sleep on it and think about it and move on with the data with the converting of entries. Oh, that's why I was doing this, because also I wanted to do that live, the prep stuff, the prep graph trip, yeah, the variables. Alright, I'll carry on with this a little later, but after I've made coffee and at a rest. The sequence of conditions, the condition is a pointer to the thing that has a rule, and the rule's p condition. So why not just point straight to that rule's p condition instead of but look, the redundant thing is actually the sequence. That's what we should be getting rid of. So I'm looking at the wrong side of it. There is an extra call, but the extra call is the sequence. We shouldn't have it. This thing literally control sequence pass calls the condition pass condition pass, which calls that rule's pass, which calls that rule's sequence pass, etc. Okay, but we shouldn't have a sequence because there is no sequence. So what should happen is the root rule should straight call that p, and that part should disappear. In fact, we don't need the condition either. But that is true, but can we reduce it even further? That's my question. Or must there be at least those two layers? I don't know, I need a coffee break, and then I may move to the office because I need to convert entries. Japanese. Oh. root rule, parse root rule. Why have that? Why not just go straight to that? Root rules p parse condition. Why not just have root rules parse condition be I don't know, that makes sense. Probably not. Look, in theory it is unnecessary because like that is literally random. Like if audio A equals B, B equals C, C equals D, and D is finally check for a root, check for an element called whatever, lemma, okay. And obviously that is in a sense redundant. From a conceptual perspective, we can skip, if we were intelligent and optimizing, we could skip, so I think that's also why I'm confusing myself slightly. In theory, that's the optimal graph, but this is information. The fact that it's a B, C, D, like, it's important information, like, and it adds structure to give an example, if the like a lemma, it is consists of one or more senses, okay, and the sensor consists of definitions and examples, optional examples or whatever, and a definition consists of a text node, and an example consists of, or a element, let me see, example, then yeah, whatever. I'll say the example is in brackets, then yeah, so we just have text in brackets, that's the example. Something like that. So it's not necessarily about having the most optimal graph, although I should keep the graph optimal, I shouldn't put a waste in there. Like, the question is, main def group may just be redundant, like I can probably delete it and every single pause would speed up. But if there is a main def group, it's in the wrong place. Like, even so, as it is now. So I can get rid of main def group, because the main def group is not there where I put it. So I can definitely optimize this already. Oh no, there is no main def group. Root is a lemma. No, root is a lemma, that's correct. And a lemma is an element lemma, a lemma rule is an element value lemma. Yeah, so there's one layer I could remove. Actually, I can't. Yeah, no, it's structure and it's already quite optimal. That's already pretty optimal. I could remove one layer at best, but it becomes less friendly to use. It's not worth it. But I don't know what's... This whole sequence thing, I don't know if it should exist like this. Probably, but let's just look at the other cases again. There aren't that many cases. There's a rule match. The annoying thing about having the extra function call is we're already using quite a lot of stack. We got, well, not really, 4 pointers and references, a 16 byte stack per call. But the other thing is we can't inline this. So I can't optimize it away with the inline because this is a virtual function. You can't inline virtual functions, can you? Doesn't make sense to me. Pause condition test. What I can do is get rid of the freaking sequence where we don't have to have a sequence. And that so yeah, where do we create the sequence? Okay, the main new sequence. Definition optional. This just has appointed another condition and just does something like this. Okay. Returns true no matter what. It still searches for a match. I'm not sure. Okay, not sure if it should make copies of my data. Or function should do that. It's a bit confusing, the delineation of responsibility here. So a pause conditional, we just wrap the other condition, right? So if we're loading and we create a pause condition sequence, no, not the pause condition sequence, although then we could do optional sequences, but that's optional sequence not necessary because I already handle that by just defining them as child rules. But the this part here where we do that, instead of that, we should be doing this, okay? If optional, condition would be optional. But now we're handling that twice, aren't we? Huh? So this should be something like this, but that also doesn't quite make sense because actually it does make sense. But then the caller of that must change, the logic there. Not sure if this makes sense. Okay, so that goes to an optional. So we're going back to using that instead of S match rule, just to test. Then in pause condition, yeah, this will always return true. It can't fail if it's optional, it'll return true. Oh, but that's wrong because that's very explicitly wrong. Alright, I think what needs to happen is this, the pause condition stuff, yeah, it must become the called function's responsibility to handle that in a p-pause condition. And in fact, the only thing we use this for is the sequence. And the ORs and the sequences, and they already do that. Do we even use it for the ORs? No. We never set a pause condition to OR currently, we might later. Why not? No, it doesn't make sense. It's just one. Look, we might later, like, if we started adding the ability to do this, like say, A equals rule, like, an OR inside a sequence could look like this. We'll see rule D, rule A, C, D, E, maybe C, D, E, yeah, okay. That could then be a pause OR as a p-pause condition. So then we'd have a sequence, conditions, okay. See, I don't think the condition, I'm not even sure a condition should exist. That's, you know, or if it should just actually all just be, you know, these weird graph classes. And then that could be an OR with two parts. The OR, yeah, that has an array. CMD. That's p-pause condition. That could be a p-pause condition OR. P-pause condition equals. Okay. See, I was thinking about that already. P-pause condition is an optional or a rule. That's it. No. I'll also use it for the other thing. The only time a sequence gets created, yeah, that's it. The only other thing we have is a sequence. And sequences only get created attached to rules. That's also a bit confusing. Why isn't it just the other way around? Why don't these things point to rules? Rules generate graph. You see, this whole thing is wrong. A rule points to graph. No, there should just be a graph. And there should be rules. And the rules generate the graph. But we do need to know the rules in the end. We do need pointers back to the rules. I don't know what I'm doing anymore, but this is a pain to do syntactically. That's why I don't want to do it now. Because I can't then switch a comma. I have to write a proper parser. I'm doing really simplistic parsing for this file format. I don't want to. And the thing is, you can handle it anyway, but just saying rule foo and foo equals a comma. You can't do this though. The optionals must be around individual rules as well. So it's a lot less fancy than it looks. I'm kidding. Why do rules have pointers to parser graph nodes? Is that the correct way of conceptualizing this whole thing? Because rules are just rules, okay? They just like say, okay, this is our syntax. And then from that springs a parser graph. And then you have parser logic, which takes the parser graph. And the only thing you want to know, actually, the only thing you really want to know, there's two reasons we want to know the rules, is because we want things to be named. Like I want to see, okay, that's the definition, that's the morphology information, and that's the cross-reference. And the rule tells you that, basically. And the other reason I want the rules is to do the fancy switching stuff. I want to be able to create, you know, yeah, we have 4 different variations, and I just comment out the one I'm not using. So I want to be able to do that live. I want to load 4 different rules for LLM kids and have an option. Select option 1, option 2, and it must apply it live in front of my eyes. Little checkboxes or to turn things on and off or something. Alright, so but this story of the optional then, okay, but then what I was confirming is that nothing here uses this. Now I'm really changing the logic here. If this, no, but we can't just assume this thing. What? Call parse condition test. If we have a parse condition, I'm handling the optional logic, yeah, but I want the optional logic to be inside that. What does that mean? Skip to next condition is the same as if true, because that's what it'll do anyway, skip to the next condition. The only thing we do if successful, so basically what it means is we, instead of passing in a copy, the call function must indeed make a copy. Okay. At least for the optional case. So the call function will do this, okay? And here it must be null. It's a serious grievance. Okay, so we always return true, but only if that thing says true, then we, because remember this is a reference, we advance a match path. And what's passed in, it's a reference to so when does OR get called? When the rules condition gets called. Oh, yes, so the ORs can get called all over the place at the S match rule thing. Okay, other parts, please. Still not convinced this must exist. Alright, so yeah, that could be an OR currently. So again, it's passing in a copy. Not convinced about that. That can be an OR. Jar rules, and yeah, pass condition, this can't currently be an OR, but so instead of doing that, we pass in it's going to do that. It's going to make a copy. And only if successful, we'll put it on the back of that for us. Match, sorry, pull this around. So it'll do this for us. Whether it's successful or not. Yo, I'm already tearing up this code now. That again is either currently, the only thing it can be is, can it be a sequence? Not currently. This is the only thing it can be. But no, I used it for something else. Nothing else set because condition. That means it's not used. That's bullshit, it is used. Because condition equals it was used. Yes. Because the rule used to be a list of conditions. And then the condition had an OR, and then I thought, well, what's the point of that one condition with the OR? Let's just make that a pointer instead of an array of conditions. Okay. So this now rule stuff's the only thing that's used for. Okay. So there's two cases. It's either a rule or it's optional rule. Okay. If it's a rule, then we do want it to do the copy stuff now. Because we're not going to do the copy stuff. There. Okay. So we make a copy, and if the rule returns true, advance, else return false. But now we're going to make a copy twice, because the optional has a wrapper to this. But that means the optional doesn't need to do it anymore, or does it? I don't know, let me think about that in a second. Node equals node copy, and there's our create a dedicated class for optional rule, and then there's not two layers. Or optional could just be a flag in here. Optional, yes, no. It's probably faster than a virtual function call and an extra stack push. But then the concept should be in the base class. Let me think about that, because maybe it also relates to things like one or more. I should actually use question mark for optional, like a regular expression, instead of that. Why? I don't know. That or that or that. Okay, so if we have a match rule, it's non-optional, it's going to do it like this inside this function. That shouldn't affect speed at all, because all I've done is take that out of here and move it into the function. Which is a bit strange, because if it's a match, if it's not a match. Okay, so we can actually leave that stuff there. Yeah, if it returns false, it's definitely a failure. But what I'm a bit confused about now is this one, the optional story. Okay. Because now all we're going to do is make a copy, and then that's going to make a copy as well. We don't need to make a copy, because that thing makes a copy. So that thing will only advance if there was success. All we need to do is return true. The thing we're calling this job is it's a bit misleading though, because an optional will always return true. Oh, but that's fine. That's exactly what it should do, because it just skips to the next condition, behaving like optional. A flag is faster than an extra layer virtual function call, to be honest. So maybe it's still better to do it like with a flag. But like I guarantee you that check is faster than using a whole extra layer of this function call, all its variables, and a virtual method table lookup, because it's a virtual function. And that's just checking a flag somewhere in memory. Well, yeah, it's still an if, but yeah, let's just see what that does. And if it still returns the same 25,222, or if I've broken things. I really need coffee. Find all nodes of this type that match bars. Something looks wrong. Shouldn't be there flickering like that menu. That means it's going to crash. It's a stack. Yeah. I think that is recursion. Stack Overflow, probably. So if it's optional, we create an optional. Set the optional's condition to the rule. And conditions pass condition to the optional, looks right. And probably somewhere something is rule match, rule map. And we should curse if rule condition pass condition test. Whatever I've done wrong, can't be too so yeah, it can fail. If it's a normal rule and the rule fails, then we'll hit here and it should return false. can't see anything wrong. So in theory, I think the whole condition thing doesn't need to exist. And we could just have the array be something that calls virtual functions for every type of scenario that we have. What's wrong? I'm going to run in debug mode to see what's happening, because when everything looks straightforward. Just double check that logic of the so parse condition test. If it failed, the only thing that can be currently is a rule, because I don't use this for anything else. A normal condition match rule, and that will internally handle. I don't need to know whether it succeeded. It'll internally XML, find the rule in the map, original return false, image recurse native copy, make a copy of native, and if rule the condition, unless I've created, unless it's pointing to the wrong rule. Let's just see. I doubt it though. This rule is see what I can do next is get rid of the sequence if there's only one. But this code is becoming confusing now. A few years from now, I'm not going to know what this code is about. I must keep these videos. Still building. Yeah, I must go to the office soon. I just want to fix this crash and finish this coffee. I may or may not stream again later when I get to the office. Backups. Okay, for debug mode, everything's super slow. So, I don't want profile right now. I'm trying to fix the crash. So I unload a smaller document because it'll take too long to load the full document. Yeah, like normal crashes in your application will give an exception failure. But Stack Overflows in Windows tend to not give an exception. Like the application just not a catchable exception frequently. The application just tends to rapidly exit. Or some such. The this parser stuff is so cool. It's so powerful. I wish that it was something all of our users were using every day, just so that they could appreciate it, because it's really it's so cool. Find filter entries all nodes, right? But it crashes right now, so it's not very cool at this very moment. I'm not even sure it's a Stack Overflow. I might be talking shit. Okay, so see what's going on. If string contains... Okay, that's just doing ordinary parsing. Which that's just an id condition text. Okay, there's definitely something going on with the optionals. Look at this crazy stack. Holy moly. But okay, the stuff up here could be, yeah, look at that stack. I mean, the finite state parsing can eat stack space. Like, look, but no, something's wrong. It's not because we're eating too much stack space now. Because the stack space I've actually already, yeah, it's either similar to what it was. All I've done is okay, optional. I think what's happening is, wait, parse optional. The maximum number of stack frames supported by Visual Studio has been exceeded. I can't even see the bottom of my stack because Visual Studio can't show me. Alright, but the parse condition test, parse should we maybe if it's optional? No, I'm sure the logic's the same, man. If it's optional, the caller must still go on to the next rule, regardless. Okay. The rules condition. Okay. JMP rule is a definition only. Checking for definition only. And that is and that rules condition calls a sequence. I've somehow changed the logic. The optional can't fail per se. It can only fail to advance the node. Let's just check what happens if we get to the end here. Is it the same as continue? It should be, yeah. Skip to next condition. Right. So definitely only. So now we're in a sequence, and the sequence comes across a parse condition looking for a rule. That rule, it's not p rule, but you know, it comes across the optional rule. Okay, for definition only, which checks if we match definition only. Okay, optionally, which calls match rule. Just passing in the same parameters. MP rule is a definition only. Its condition is a sequence. This is inefficient, those things. But that's not. Oh, look, there's a bug. Oh, no, it's right. Yes, no, wait. That should be match recurse. Yes. Whoops. Okay, that was wrong. So it'll never that still shouldn't cause a crash though. So what it was doing, we'd have a match recurse and it would, if not match recurse empty, then add it to match fill this round. So now we're just passing those in by reference and letting the function we're calling do the same thing. Tiny test, it's one even smaller. Don't want to sit here waiting for the document to load for half an hour. Element final entries of the started match parser. I don't think that's the bug. There's another bug, yeah, damn it. Same Stack Overflow. Oh, I see the other problem. Correct. Should pass node each copy in to it shouldn't crash. That shouldn't cause it to crash though. That should just cause it to eat up too many nodes and fail sooner rather than later. Because it'll never rewind on a failed parse path. It won't rewind the node pointer. So there's still something else wrong, I think. And 0 of 39, okay. Now let's load small filtered. I want to go to the office and go do some conversions. Element node and all nodes of this type that match the parser. You know, even on a good day, this stuff is going to eat stack. I'm expecting I may hit stack problems, and then I may have to refactor some things. Or just find another way to break down the task into smaller chunks, like pre-subgroup the entries. Let's just break in debug break all. I want to see what the stack looks like. I didn't yeah, it should be quite minimal, but yeah, it's gonna the stack, yeah, it may explode when it shouldn't actually. Okay, that worked. It's working view and working correctly. So let's go back to release mode. I think it was just that simple little problem that I had there. And then the only thing I need to do to make this optimization is get rid of the sequence. Get rid of the sequence node if we only have one rule. Doing things like what I'm doing now and using this optional, I'm putting all the logic in this finite state graph instead of having it all. It's a little bit all in a big if this do that, if this do that. You know, I'm curious to see if this affects speed in any notable way. It shouldn't. It should be very close to what it was. Could be pip slower. It can't really be faster. You know, what I've done now should not. It should be the same. It should be negligibly different, but possibly slightly slower. But like 1% slower. And because I'm having an extra function call, one or two extra function calls, and like the optional logic is now, yeah, the speed's the same. This, yeah, it's about 3 seconds, 2.9, 2789 milliseconds, 2904 milliseconds, maybe a pip slower, which is what I would expect. Ways to speed it up would be, yeah, there's other ways. But it's so fast. I mean, look, it's doing 11 million nodes in a big complex document tree of 206,000 entries in 2.7 seconds. You know, to run all these parsing rules to identify 25,200 entries while I'm streaming, you know, it's definitely already very fast. But you know, it doesn't really need, it's not screaming optimize me, but load, yeah, so load. So basically, if parse condition sequence, yeah, so if sequence semi conditions push back condition, right? So I'm going to do this slightly differently. I'm going to just push back a vector of conditions again, like I used to have it. A conditions, and then at the end of that, if conditions.size equals 1 and the condition is a parse condition, then we don't need any sequence node at all. This might slightly speed things up or bring it back where it was, down to the range of 26 milliseconds, 2600 maybe. So conditions that can you stay there, push back, okay. So we skip the sequence entirely. We're going to create a sequence. Create a sequence if we end up with more than one row in the sequence, if only one, and it's a normal abstract p parse condition. We can optimize away the sequence of one condition in the array and just go straight to the, can we? Yes. We're recalling that it will be responsible for the it copy stuff. Not it copy stuff. Okay. So here we're going to create the sequence. Fuck the sequence. Okay, if more than one OR factor, add this current sequence of conditions to the new sequence branch. Two or more conditions in sequence. So if a P OR, then create a new, push it back, else it's just one main sequence. Now, if there's only one, then we also need to test if P OR when do we set the rule? Condition thing. Ooh, this is now wrong. Wait, what? Oh no, wait, this must be right. Yeah, this only creates pre-rule condition is either or the main sequence. So this is now wrong. Because what? Huh? If OR factors yeah, we don't need a sequence main. Yeah, if there's a so if there's an OR, then then all we need to do is do this. Okay, if there's an OR, then push back that and then never look at it again. Else if there's no or, it means we have only one factor and it has one condition. So the rule pointer can be p-parse condition. If there's an or, it means add a branch to the or. Options, it's just a single parse condition instead of sequence. Optimization. Stuff is to create optimal graph. If there's an or, then we create the sequence and put it back. If there's not an or, but there's two or more conditions in the sequence, then this isn't right yet. It'll be interesting to see if, yeah, I think we might get down to 2600 milliseconds from this, but it's still, I think, a good thing to do. Alright, parse condition sequence star sequence main equals null. I don't think we should have that at all. Sequence main, it doesn't make sense. Okay. If we have yeah, so if we only have one condition and it's a parse condition for a sequence and we have no or, okay, then yeah, the rule condition is just the parse condition, straight, faster. If there's an or, and this is also faster than the current implementation, if there's only one. So yeah, just to bring it back to real cases, so that'll be like if root equals a or b becomes c, right? Then that'll create an or, and the or will have two branches. And branch 1 will just be a direct rule pointer, and rule 2 will be the branch 2 will be a sequence. Okay. If we have like root equals a, then we'll just have literally a straight rule pointer. That's what we want. Okay. If root equals a or b, then we should have an or with two rule pointers. And if root is just a comma b, then we should have just one single sequence. A, comma B. Basically, okay. Let's put that in here. Crappy documentation, but anyway. If root is A, or so that's basically, we want the minimal number of sequence nodes as possible. C power or a rule pointer and a rule pointer. So if we have a sequence but we don't have an OR, if we don't have an OR, it means it's the fourth case. Then we will be condition. So we create a sequence main, but then we need to set its conditions to the array of conditions. Okay. Two more conditions in sequence. But I'm just worried if, remember this is getting called in the I loop for each set of factors. So if there are 3 or more factors, we don't want to do this every time. If there's factors, there'll be an OR. Yeah, if there's factors, there'll be an OR. The OR is null, and we know the I loop runs only once. So this will happen only once. Okay. I think that's right. P sequence. Okay, so we need the sequence either way, right? We must create a sequence. So let's just do it thus. So that's to handle this. So we try to create the optimal graph, depending on, like, for these different 4 cases. You know, this is in 2 OR factors. The second one has a sequence. Sequence is comma separated stuff. Okay, that's just a simple rule, and it should only create a direct rule pointer for that case, and that should be if we have that's this case. Okay, that's the first case. Let's label these case A, or case 1, case 2, case 3, case 4, and now case 1. And let's just use lowercase everywhere. ADC, DC, alright, reduce AB. One or three. Case 3 A or B. Case 1A. Case 1B, comma C. No, that's not case 1. That's case 2. So that's a sequence. That's case 1B, comma C. Case 1B, comma C specifically. B, comma C side. And that's just case 4. Okay. Be interesting if this actually works, or if it also crashes, and also then I have to go run this debugger to figure out why. Must be careful. I've made changes. I don't want changes. Okay, revert. It cannot be slower. It can either than it was before. Literally, because all I've done is take the same logic and optimize the graph. It's got the correct results, 25,222. So speed-wise, same. So that's same. So that's negligible. It must be faster, but it's negligibly faster. Like, it's just in the noise. 2,800. Hopefully, as I make the graph, the bars are more complex, the guns will maybe be useful. But yeah, that's just in the noise. I really 2795, 2855, 2788, I'll run a test now with the, I wonder if it'll make any difference. I'll tick the process priority higher and kick down the OV, like the streaming. I doubt it'll really make a difference, to be honest. You would think it would, but yeah, I got a 2622 there, 2712. So yeah, we're getting down to the 2600 range again. That's what I thought. But yeah, it's marginal. So basically now, if we go look at that other file, what I've done now is basically get rid of this intermediate story. And now we have this, what we want. Root directly becomes a that. That becomes a that. What I could speed up again is the optional stuff. The optional stuff could just be done with a flag. It'll be faster than doing it as a node. But you know, it's going to be like 50 milliseconds. It'll be like change it from 2650 to 50 milliseconds. If I'm doing big pauses later, then I start to need the speed. I can look at that, I guess. But right, I'll see you again at the office.